Hi, in this video I'm going to show you how to use the R language to classify a multispectral image through the algorithms known as random forests for obtaining a land cover classification. First, let's load the packages necessary for image processing. Let's import into R the image, in this case a Landsat 7 scene, as a raster brick object. The band names of the imported image are a bit long and complicated, so let's replace them for shorter ones. For this exercise, I have created a set of training areas, which are polygons identifying the land cover types found in this image. In the attribute table of this shapefile, I have a column called class that stores the IDs for each land cover type. I'm going to use this column as a response variable for the model that will be fitted for the classification. Let's import this file into R using the shapefile function. Also, let's create a new variable to store the column name from the attribute table with land cover type IDs. The next step is to extract for all the training polygons all the pixel values in each band of the Landsat image for every land cover type. I'm going to store all those values in a new data frame that I have called this way. This process may take a couple of minutes, so I'm going to pause the video for a moment. Okay, we can see that the extraction of values from all the training areas has finished. The resulting data frame has about 80,000 rows. A data frame this size can take a long time for training and fitting the random forest model. So let's create a data subset in order to work with a smaller data set. Here I'm going to take only 1,000 random samples and I'm going to store them in this new data frame. Now we can train and fit the model. We can specify the model as a formula with the response column encoded as factors. I am going to use only 3 image bands as explanatory variables: red, near infrared, and shortwave infrared bands. Here we define the classification algorithm, in this case random forests. We could use any of the methods available in the current package, like support vector machines or others. We also specify the data frame where the data are stored. We can see some info about the fitted model. It is based on 1,000 samples and 6 predictor classes. We also get here some estimate of the accuracy based on the training data. After model fitting, we could use the predict function for the classification, providing the image name and the fitted model object. However, we can use the raster package capability for parallel processing in order to speed up computations. We need to add these 2 lines. This first line creates a cluster object and determines the number of cores in the computer and use them all. This other line deletes the cluster object after the computation is finished. So we use the cluster R function for parallel processing, specifying the arguments needed for the image classification. I am going to measure the time this process takes. Okay, let's run this part of the code. This is going to take a couple of minutes, so I'll pause the video again. Okay, the classification is done. This process took about 4 minutes. Without parallel processing, the classification of this image would have taken about 15 minutes in this computer. We can see some info about the resulting object. So it is a raster layer with this range for pixel values. We can plot in RStudio the classified image, so we can visualize the result of the classification process conducted with the random forest algorithm. We see here the image. The pixels have values between 1 and 7. Finally, if we want to export this object as an image file, for example in TIFF format to open it later in another program, we use the write raster function. We have to specify the object name and the output file name with the corresponding file extension. Okay, as you can see, the R script for image classification with random forest is quite simple. We can use random forest or any of the classification methods available in the guided package. If you want to know more about this process, I invite you to read the post in my blog about this topic. The link is in the description section of this video. Hope you find this video useful. Thanks for watching.